Good morning, students. In the previous class, that is class 2 of the chapter Oxygen family, that is group 16 element, I completed the method of preparation, property and uses of dioxygen, then oxides, different types of oxide, simple oxide, mixed oxide, acidic oxide, basic oxide, amphoteric oxide, neutral oxide, and then method of preparation, property, uses of ozone. Especially method of preparation ozone by Simon ozonizer, preparation property of ozone. Today, that is class 3 of this chapter, I will try to complete the allotropic form of sulfur, the method of preparation, property, uses of sulfur dioxide, the oxoacid of sulfur, and finally, the method of preparation, property, uses of sulfuric acid. So let us discuss one by one. First one is allotropic form of sulfur. Mark that. First one is allotropic form of sulfur. What do you mean by allotropic form? Various form of the same element having similar chemical properties but differ in their physical appearance. It is known as allotropic form and the phenomenon is known as allotropy. I repeat again. The various form of the same element having similar chemical properties but differ in their physical properties known as allotropic form and the phenomenon is known as allotropy. Generally, sulfur possesses 5 types of allotropic form, that is rhombic sulfur, monoclinic sulfur, colloidal sulfur, plastic sulfur and milk of sulfur. These are, first one is rhombic sulfur, next monoclinic sulfur, next colloidal sulfur, next plastic sulfur, and last one is milk of sulfur. These are the following allotropic form of sulfur. Different, I repeat again, what do you mean by allotropic form? Various form of the one element having similar chemical property but different physical properties. Next we discuss about the method of preparation of sulfur dioxide. Next, method of preparation of sulfur dioxide. Methods of preparation of sulfur dioxide. There are 2 to 3 methods are there. Let us discuss one by one. First method is by roasting metal sulfide. Mark that. First method by roasting metal sulfide. That is metals like iron, zinc, lead. When their sulfide strongly heated, result in the formation of sulfur dioxide. Mark the equation. 4FeS2 plus 11O2 give rise to Fe2O3 plus 8SO2. Then zinc sulfide plus oxygen give rise to zinc oxide plus SO2. lead sulfide plus oxygen give rise to lead dioxide plus SO2. These are the method of preparation. First one is by roasting metal sulfide in air. It is the first method. Move to the second method, that is by the action of dilute acid with sulfite, bisulfite and thiosulfate. Mark the second method of preparation, that is by the action of dilute acid. Second method is by the action of dilute acid with sulfite, bisulfite and thiosulfate. That is when metal sulfide, bisulfite and thiosulfate treated with a dilute acid resulting in the formation of sulfur dioxide. Mark the equation, that is metal sulfide Na2SO3 plus HCl give rise to NaCl plus SO2 plus HCl. NaCl plus SO2 plus H2O. Next, it is sodium sulfide. Next, sodium bisulfide NaHSO3 plus HCl give rise to NaCl plus SO2 plus H2O. Next, sodium sulfide, sodium bisulfide and thiosulfate Na2H2O3 plus HCl give rise to NaCl plus SO2 plus S plus H2O. It is the second method, that is by the action of dilute acid with sulfite, bisulfite and thiosulfate. Move to third method, that is a laboratory method of preparation. Third method, that is laboratory method of preparation. Third method, that is by laboratory methods of preparation. That is, in the laboratory, sulfur dioxide is prepared by action with concentrated sulfuric acid with copper chips. Mark that. Copper plus sulfuric acid concentrated give rise to copper sulfate plus sulfur dioxide plus H2O. It is the laboratory method of preparation. This sulfur dioxide gas is collected by the upward displacement of air, and it is purified by passing through concentrated sulfuric acid. Quick lime, a question may arises, quick lime is well known drying agent, but why sulfur dioxide is not dried by passing through quick lime? Answer is because it combines with to form different compound. Mark that. Calcium oxide plus sulfur dioxide to form calcium sulfide. Due to the formation of another compound, though quick lime, it is known as quick lime. Those quick lime is well known drying agent, yet it is not used for drying sulfur dioxide gas. It is all about the method of preparation of sulfur dioxide. Next, switch over to the chemical property. Next, chemical properties of sulfur dioxide. First one is chemical properties. First one is acidic nature. First property, acidic nature. Mark that. When aqueous solution of sulfur dioxide, mark that. SO2 plus H2O give rise to H2SO3. SO2 plus H2 give rise to H2SO3. That is sulfurous acid. As it is acid, so aqueous solution of sulfur dioxide is acidic in nature. It changes blue litmus to red. As it is acidic in nature, it combines with different bases, resulting in the formation of salt and water. Next chemical property is move to the second chemical property, action with quicklime. The second chemical property, that is action with quicklime. Action with quicklime, that is calcium hydroxide. When sulfur dioxide gas pass through quicklime, when sulfur dioxide gas pass through quicklime, the solution becomes milky due to the formation of insoluble salt. Very important to our question. What happened when SO2 gas bubbled through quicklime? Answer: the solution becomes milky due to the formation of insoluble salt. But on the other hand, if this gas passes through the quicklime for a long time period, the milkiness disappears due to the formation of a soluble salt. Again, it is another 2-mark question. What happens when SO2 gas passes through quicklime for a long time period? Answer: milkiness disappears due to the formation of a soluble salt. Mark that equation. Calcium hydroxide plus sulfur dioxide give rise to calcium sulfide plus calcium sulfide. Milkiness appear due to the formation of insoluble salt. But if SO2 gas pass through for a long time, resulting in the formation of calcium bisulfite, soluble salt, so milkiness disappear. Very important to our question. What happened when lime water pass through? What happened when SO2 gas pass through lime water? Next, move to third chemical property, that is reducing nature. Move to third chemical property, that is reducing nature of sulfur dioxide. Third chemical property, that is reducing nature. Aqueous solution of sulfur dioxide, that means when sulfur dioxide in presence of moisture behaves as a reducing agent due to liberation of nascent hydrogen. I repeat again. Dry sulfur dioxide never behave as a reducing agent, but in presence of moisture it acts as a reducing agent due to liberation of nascent hydrogen. It also accepts nascent oxygen. Mark the equation. SO2 plus H2O give rise to H2SO4 plus nascent hydrogen. In other words, also SO2 plus H2O plus nascent oxygen give rise to H2SO4. Since it liberates nascent hydrogen, therefore sulfur dioxide in presence of moisture behaves as a reducing agent. For example, let us consider 2 to 3 examples. That means it reduces halogen to halogen acid. It decolorizes the pink color. It decolorizes the pink color of acidified potassium permanganate. It changes the orange color of acidified potassium dichromate to green. It reduces ferric salt to ferrous salt. Let us discuss one by one. First one, it reduces ferric salt to ferrous salt, that is ferric sulfate Fe2SO4 whole thrice plus SO2 plus H2O give rise to FeSO4 plus H2SO4. It reduces ferric sulfate to ferrous sulfate. Next, it decolorizes the pink color of acidified potassium permanganate solution. Acidified potassium permanganate is a pink color. It decolorizes the acidified potassium permanganate. Mark the equation. KMnO4 plus SO2 plus H2O give rise to K2SO4 plus MnSO4 plus H2SO4. It is pink color. It is colorless. That is pink color changes to colorless. Next, it changes the orange color of acidified potassium dichromate to green. Mark that. Next one is it changes green color of acidified potassium dichromate solution to which changes orange color to green. Mark that. It changes orange color of acidified potassium dichromate solution to green. Mark the equation. K2Cr2O7 plus H2SO4 plus SO2 give rise to K2SO4 plus Cr2SO4 whole thrice plus H2. It is orange color. It is green. That means orange color transfer to green color. Next, it reduces halogen to halogen acid. Next point. It reduces halogen to halo acid. Mark that. Cl2 plus SO2 plus H2O give rise to HCl plus H2SO4. That means here chlorine transfer to hydrochloric acid. These are some examples under the reducing nature. Next we discuss about bleaching nature of sulfur dioxide. Next chemical property, that is bleaching action of sulfur dioxide. Sulfur dioxide in presence of moisture acts as a bleaching agent. And again, sulfur dioxide in presence of moisture behaves as a bleaching agent and it is due to its reducing nature. That means the vegetable coloring matter bleaches to vegetable colorless matter. However, this bleaching nature is temporary because when the colorless vegetable matter came in contact with the atmospheric oxygen, get oxidized and regain its original color. That's why bleaching action of sulfur dioxide is temporary. Mark the equation. SO2 plus H2O give rise to H2SO4 plus nascent hydrogen. Due to the nascent hydrogen, the bleaching action of SO2 is due to its reduction. Mark that. Vegetable coloring matter plus nascent hydrogen give rise to vegetable colorless matter. However, when vegetable colorless matter came in contact with atmospheric oxygen, get oxidized and regain its original color, that is vegetable coloring matter. That's why bleaching action of SO2 is temporary. Very, very important 1 mark question. Bleaching action of sulfur dioxide is due to its reducing nature and bleaching action of SO2 is temporary. Next we discuss about the uses. Next, uses of sulfur dioxide. So many uses of sulfur dioxide are there. Point 1. It is used in the manufacture of sulfuric acid by contact process. Mark that. Point 1. It is used in the manufacture of sulfuric acid by contact process. Next, it is used as a bleaching agent. Next, it is used as a germicide. Next, it is used, next uses of sulfur dioxide, it is used as an anti-chlor. This is very, very important one. What do you mean by anti-chlor? That means during chlorination, excess chlorine if is there, then the sulfur dioxide is used to remove the excess chlorine. These are some uses of sulfur dioxide. Next, switch over to the oxoacid of sulfur dioxide. Next is oxoacid of sulfur. Sulfur form a large number of oxoacid. For example, sulfurous acid, sulfuric acid, peroxy monosulfuric acid, peroxy disulfuric acid, oleum, so many are there. For example, H2SO3, H2SO4, H2SO5, H2H2O7, H2H2O8. its name is sulfurous acid, its name is sulfuric acid, its name is peroxo-monosulfuric acid, peroxo-monosulfuric acid, other name is Carros acid, it is oleum, it is peroxo disulfuric acid, or it is known as Marsal acid. These are some examples of oxo acid. Next, move to the method of preparation of sulfuric acid by contact process. Next, we discuss that is method of preparation of sulfuric acid by contact process. First one is principle. What is the principle behind it? The sulfur dioxide which is formed by the combustion of sulfur or by roasting metal sulfide, that is iron sulfide, is converted to sulfur trioxide. I repeat again. The sulfur dioxide which is formed by the roasting of sulfur, that means S plus O2, SO2, or by roasting of iron pyrite, then it is converted to sulfur dioxide by combustion in presence of temperature 450 to 500 degrees Celsius and 2 atmospheric pressure, and in presence of catalyst, that is platinized asbestos or vanadium pentoxide. The sulfur dioxide form, then react with 100% sulfuric acid to form oleum, and finally oleum is diluted to form desired concentration of sulfuric acid. It is the principle. Next we switch over to the theory. Next one is theory. Bit 1, formation of sulfur dioxide. First step is formation of sulfur dioxide. Two different ways are there. Either the burning of sulfur direct or by roasting metal sulfide. Means S plus O2 give rise to SO2, or 4FeS2 plus 11O2 give rise to 2Fe2O3 plus 8SO2. Either burning of sulfur or roasting of iron pyrite. In this way, first step, sulfur dioxide is formed. Second step, conversion of sulfur dioxide to sulfur trioxide. Move to next step. Next step is, that is conversion of sulfur dioxide to sulfur trioxide. That means when oxidation of sulfur dioxide takes place, resulting in the formation of sulfur trioxide. Mark the equation. That is SO2 plus O2 give rise to SO3. Del H is equal to negative gas. Mark that. When SO2 undergoes oxidation, resulting in the formation of SO3. As it is exothermic reaction, according to the application of Lee-Chatterjee principle. Applying Lee-Chatterjee principle, the favorable condition for maximum yield of sulfur dioxide is point 1, that is low temperature, as it is exothermic reaction, that is low temperature, that is optimum temperature equal to 720 Kelvin. Mark that reactant side 3 volume, product side 2 volume, low volume, so high pressure, that is optimum pressure is equal to 2 atm. Next, pure and dry form of SO2 and O2, and finally at the initial step platinized asbestos was taken as the catalyst, but two demerit is there. Cost is high, and if by any mistake any impurity is present, then it combines with the impurity, making the solution poison. So later on, with the development of science, platinized asbestos is replaced by vanadium pentoxide. So vanadium pentoxide is used as a catalyst. These are the favorable conditions for formation of more amount of sulfur trioxide. Next, the sulfur trioxide dissolve with 100% pure sulfuric acid to form oleum, and finally oleum diluted to form desired concentration of sulfuric acid. Mark the equation, that is sulfur trioxide form SO3 plus H2SO4 to form H2H2O7, that is known as oleum, and oleum form dissolve with water to form desired concentration of sulfuric acid. It is the method of preparation, it is the total theory of manufacture of sulfuric acid by contact process. Next is over to the physical property of sulfuric acid. Next, discuss about the physical properties of sulfuric acid. It is a strong acid, dibasic acid. It is syrup in nature. It has high density. Otherwise, the sulfuric acid is known as oil of vitriol. It has high boiling point. It is viscous in nature due to the presence of intermolecular hydrogen bonding. It is highly corrosive, and when it came in contact with her skin, produces blister. It is highly soluble. It has a strong attraction towards water. So, when concentrated sulfuric acid is diluted, it is advised to add acid to a container containing water, but not reverse. As it is an exothermic reaction, to avoid accident, it is always advised, whenever necessary to prepare dilute sulfuric acid, add sulfuric acid to a container having water. It is all about the physical property. Next, switch over to the chemical property of sulfuric acid. Next is chemical property of sulfuric acid. First one is acidic nature. We know sulfuric acid is a strong acid and it is a dibasic acid. That's why when it is combined with base, it forms two type of series of salt. For example, sodium hydroxide plus sulfuric acid give rise to sodium bisulfate plus water. Sodium hydroxide plus sulfuric acid give rise to sodium sulfate plus water. These are some examples. As the dibasic acid form two type of series of salt. As it is an acid combines with active metal, combines with the metal liberating hydrogen. Mark that. That is zinc plus sulfuric acid give rise to zinc sulfate plus hydrogen. Magnesium plus sulfuric acid give rise to magnesium sulfate plus hydrogen. As it is acid, it combines with carbonate, bicarbonate, resulting in the evolution of carbon dioxide. Mark the equation. Carbonate plus sulfuric acid give rise to sodium sulfate plus carbon dioxide plus water. Sodium bicarbonate plus sulfuric acid give rise to sodium sulfate plus carbon dioxide plus water. These are some examples under the acidic nature of sulfuric acid. Next, switch over to oxidizing nature of sulfuric acid. Oxidizing nature. It oxidizes carbon to carbon dioxide. It oxidizes sulfur to sulfur dioxide. It oxidizes phosphorus to phosphoric acid. Mark the equation. Carbon plus sulfuric acid give rise to carbon dioxide plus sulfur dioxide plus water. Sulfur plus sulfuric acid give rise to sulfur dioxide plus water. Phosphorus plus sulfuric acid give rise to phosphoric acid H3PO4 plus SO2 plus H2. These are some common equation example verifying the oxidizing nature of sulfuric acid. Next property is dehydrating nature of sulfuric acid. Next chemical property. Next chemical property is, that is third chemical property, dehydrating nature of sulfuric acid. Concentrated sulfuric acid behaves as a dehydrating agent. So many examples are there for 0.1. That is pepper, wood, charcoal. When contact with heated with concentrated sulfuric acid, it becomes char. This process is known as charring of sugar. Very, very important. This is known as charring of sugar. Mark that. C12H22O11 concentrated sulfuric acid to form 12 carbon plus 11 H2O. It is known as char. Another one is, with example, second example, formic acid HCOOH concentrated sulfuric acid. It form carbon monoxide plus water. Next is oxalic acid, COOH, concentrated sulfuric acid form carbon monoxide plus carbon dioxide plus water. When ethyl alcohol also treated with a concentrated sulfuric acid, mark the equation. Ethyl alcohol, that is CH3CH2OH, concentrated sulfuric acid at 443 Kelvin get dehydrated, resulting in the formation of ethylene. Its name is ethyl alcohol. Similarly, when ethyl alcohol heated with concentrated sulfuric acid at 413 Kelvin dehydrated to form diethyl ether. Its name is diethyl ether. These are some common examples which verify that concentrated sulfuric acid behaves as a dehydrating agent. Next chemical property is about to precipitation reaction. Next chemical property, that is precipitation reaction. Precipitation reaction. Salts of, that is some salts, that is lead, calcium, barium, strontium salts, when treated with concentrated sulfuric acid, resulting in the formation of an precipitate. For example, lead acetate treated with sulfuric acid give rise to lead sulfate, white precipitate plus acetic acid. Its name is lead acetate. Calcium chloride plus sulfuric acid give rise to calcium sulfate plus HCl. It is white precipitate. That is barium chloride plus sulfuric acid give rise to barium sulfate, white precipitate plus hydrogen chloride. These are some examples under the precipitation reaction. Next, uses of sulfuric acid. Last one is, that is uses of sulfuric acid. Uses of sulfuric acid. So many uses of sulfuric acid is there. So many uses of sulfuric acid is there due to its vast application. Due to its vast application of sulfuric acid otherwise known as king of chemicals. Sulfuric acid is known as king of chemicals. I repeat again, due to its vast application. For example, it is used as an laboratory reagent. Which one? It is used as a laboratory reagent. It is used It is used in a lead accumulator as electrolyte. Next, it is used in the preparation of dyes, drugs, etc. It is used in petroleum refinery. It is used as a dehydrating agent. So many uses are there. Due to its vast application, the sulfuric acid, otherwise known as king of chemicals. It is all about the chapter group 16 elements or oxygen family.